Thank you, Natalie, for presenting me and for inviting me for this talk to virtually to the planet. I don't know, I don't know where are the people sitting and watching me. So today I'm going to talk about the Levantine Corridor, land bridge for early hominins migrations out of Africa and the birthplace of agriculture. So first of all, I want to show where we are. Where is the Levantine Corridor? So the Levantine Corridor is basically here, which is not only the corridor that connected the big empires of Mesopotamia and Egypt during ancient times and in the Fertile Crescent, sorry, but it's also a land bridge connecting Africa with Asia. It's basically the only land bridge. And it was the cradle of modern civilizations, at least when we're talking about the Western world. And since history, it has been in the center of developments of religions, of empires, and so on, which I'm not going to talk. Luckily, I'm a geologist. But indeed, it has been the land bridge between two large pieces of continental masses. And in many aspects, it's a part of Africa. So I like this kind of picture in which I am highlighting the Levantine Corridor, but putting it in the African context, because we are part of Africa after all, in the tectonic, at least from the tectonic point of view. And here is the tectonic framework of the region. The Levantine Corridor is very near the Dead Sea Transform, which is a transform fault, a left lateral transform fault that starts in the southern part of Egypt, of Sinai, sorry, and continues into the Red Sea Rift and to the triple junction of the Afar Dome, and eventually continues until Mozambique with the East African Rift, the two branches of it. So it's part of a series of tectonic delineations that start in Mozambique and eventually continues. I didn't put it in the map, sorry for that, but it continues until Turkey, when the Dead Sea Transform collides and joins with the Eastern Anatolian Fault, which runs east-west in southern Turkey, another triple junction kind of. So we are part of a very long tectonic framework. But if we talk about climatic point of view, we're more in the European, currently, we're not so much Africa, and more in the European climatic context by the influence of the westerlies, as we were talking earlier, when the westerlies that are dominating also the climate in the Mediterranean region in southern part of Europe. So also dominates, of course, Israel, providing with winter rains. But also, we are not so far from the impact of tropical surge of precipitation coming from the south, which is called the Red Sea trough, and which are related to monsoonal rains driven north by the ITCZ movement in July. Okay, so it's not a monsoonal rain, of course, but we are close to be, the tropical storms are affected by the monsoonal rains that arrive to this part of the planet, and which we can see very obviously by the color image here in Africa, in eastern part of Africa. So with this ITCZ movement has been going north and south basically through the time as in a precessional millennial scale modulation, which basically, in other words, have influenced the northward migration of monsoonal rain systems already since the Miocene. Okay, so the present situation, in other words, does not imply that it was the situation in the past, depending how far we go in the past, of course. And this monsoonal area, which is, in other words, kind of global monsoon region in the planet, which influenced the Far East, India, the southern part of Arabia, and of course, Africa, It's all that frame, all that area was basically moving north or south in an orbital scale of pacemaker, right? But we are coming back to the Levantine corridor. We we are located very well north of that red line that was before, north of the Sahara Arabian Desert. So that desert was formed already as a result of tectonic collision 11 million years ago, and it is a natural barrier that prevents latitudinal biological diversification. Okay, it's like a wall in which the fauna and flora, which is beneath it, the southern part of it, and dominated by these monsoonal rains, will not eventually cross that natural barrier. Of course, through time you had these oscillations in which, if I start from the beginning, already in the late Oligocene, we have the ITCZ was much north of today. We have the proto-Mediterranean connected to the Western Tethys. Here is the Para-Tethys, sorry. And we are located somewhere over there, and there is basically no Sahara over there. But as the collision started between that Africa and the Arabian part of it with Eurasia, we start to close the Western Tethys. And basically the development of the Sahara start to be more intensified with a southern movement of the ITCZ toward the late Miocene. And here we see more development of aridity and the present situation in which dominates the entire fringe of the Sahara Arabian Desert. But we know that these conditions were not all the time like that, and we had times in which the Sahara was not exactly brown as we see in this picture, for sure not so green as in this one, but much greener than less green, but it was much greener than now. It was basically look something like that probably. And this is called, the last time that we know that is the Green Sahara, which is somewhere 11 to 8,000 years ago, with an enhancement of latitudinal biological migration. Once you have broke that wall, basically you have fauna and flora migrating across the entire continent. And you have development of big lakes like Lake Meg Chad, which was 170 meters in depth. It was a very big lake and one of the biggest in the planet. So we are talking about a total different environment developing during the Holocene, the early Holocene. And basically, this is the last time in which the Sahara was actually vegetated. And the new environmental setting probably, as I mentioned, facilitated fauna and flora migration. So we have plenty of evidence for that, starting with the Lake Mega Chad that I mentioned, sediments purely diatomaceous of a freshwater lake, currently in an environment which is extremely arid, as you can see here in northern Chad. And evidence of paintings of that period, sorry, in which you see animals and flora and fauna, which obviously don't prevail and don't exist in such an environment. Again, those are findings are across the Sahara. Yet some open questions remain, especially when we are getting to the Levantine Corridor. And in this case, my open questions ask, what was actually the environmental conditions in the Levantine Corridor during the African period, which is around 11,000 years ago? Moreover, do we see similar optimal hydrological conditions during earlier periods? What is happening basically in the early Pleistocene or the Pliocene, if we go so far? And when we are talking about this early Pleistocene period, so is there a connection between past optimal hydrological conditions with hominin migration through the corridor, through the Levantine corridor? And there are important questions to understand about us as a species, how we made our own evolution and how we migrated through this area. So I'm going to show you 4 different sites in the Levantine Corridor from the north to the south with different time periods representing my talk. And we start from the present, actually, from the Neolithic Revolution, which is the spread of agriculture in the Near East, somewhere 9,000 to 3,000 before the present era. What you see here is a very nice map, actually, that shows how 9,000 years ago you have agriculture occurring in this area, in the Levantine Corridor, and in Mesopotamia, in the Fertile Crescent, actually. And through time, this was before 9,000, sorry, around 11,000 actually. And between 9,000 to 7,000, 7,000 to 5,000, 5,000 to 3,000, you have the spread of agriculture to other parts of the old world, and then eventually to the other parts of Europe, China, and Northern Africa. Actually, if I'm not wrong, I'm sorry I didn't put a reference. This is a Swiss paper, if I'm not wrong, with sites from Switzerland. Sorry for that. But if we concentrate in the Levantine Corridor, during the 11,000 years ago, we have plenty of historical and archaeological data. And what you see here, all the dots are all those archaeological sites dated for the Neolithic and implying related to the spread of agriculture. So forget the colors right now, but this is for showing this so much information that is spread around the area. Of course, the lack of information, such as in Lebanon, doesn't mean that there wasn't. This paper doesn't describe what is happening behind the current political borders. But in any case, when we are talking about one very famous site, which is in the lower part of the Jordan Valley, this will be the Sea of Galilee, the Jordan River, and the Dead Sea. So the lower part, we have the Tel El Sultan, which is a Neolithic, basically the Neolithic city of Jericho. We all probably heard about the city of Jericho, which is very well known as one, if not the oldest metropolitan congregation of people in the old world, and dated back to 9,500 years before the common area. This is Tel El Sultan, and this is the city, the fertile part, because it's very fertile, it's an oasis basically of Jericho, and the representation of how it was 9,500 years ago, with the famous walls of Jericho. And there are plenty of, again, plenty of archaeological remains showing, pointing to archaeology, agriculture. You can see this utility for cutting the harvest, for harvesting, or also that tool, a lithic tool as well, for related to agriculture, and of course grinders that they are also related. Everything dated from 2,000, 10,000 years ago. So we are talking about a very well-developed society dealing with high infrastructure and conditions for agriculture. And the same paper of Palmisano also recollect all this historical information in the Levantine region into, with the pollen data, into a record dated for the last 11,000 years, with several oscillations pointing for the different climate variabilities in the area. Okay, arboreal pollen and cultivated trees. We start with cultivated trees, very prominent somewhere about 7,000 years ago, and so on. And regional pastoral indicators starting already 10,000 years ago, and so on. But there is still a little bit of lack of information how the landscape looked like with the human interference. And thus the early Holocene anthropogenic impact had left some kind of an imprint, which we can find in the geological record of the Levantine Corridor. In other words, are we talking about an environment which look like that, okay? Vegetated with here and there some human congregation, or more than that we have more humans and less vegetative areas. Of course, this is a representation, not necessarily the typical housing that there were in the Neolithic. So there are still major unknowns. And to answer this, what we did is going to the ICDP 5017 drilling campaign in the Dead Sea, which we cored in November 2010. So this, what you see here is the watershed map of the Dead Sea, okay, with the location of the ICDP core 1517. And the data that we receive from there, these are the location of the drilling, and three different sites with two major ones. So let's say site 1A was the major one with we core 450 meters, and another one was the last one, C, which we core around 330. We started at depth. So in total, more than 700 meters of core, and several countries, in which Switzerland was there as well, were member of this consortium, scientific consortium. In any case, I'm concentrating the data on this one, but not on the full core. Of course, I want to go directly to the Holocene and talk about the subject of this talk. So this is the full core, 450 meters with the different lithology published by Neugebauer in 2014 already, with the ages both in C14 and uranium thorium. And you can see different sedimentation rates, which also represent the different lithologies. Here we have more highlights, so the sedimentation rate will be much more faster. Here and there, this light gray color, there are highlights, and this, which is a more normal, let's say what is normal, but a more typical sedimentation rate for the cold and wet marine isotope stages, which you can see here, okay? Sorry, for the warm marine isotope stages. So in any case, what we see here is, so here you see the clastic sedimentation rate, but only for the last 225,000 years. So basically we converted core in the depths into age. And you can see that the marine isotope stages, you have very different corrected clastic sedimentation rate between the interglacial and subglacial periods, okay? So with very obviously the present interglacial, the Holocene, has ×3 sedimentation rate that the previous marine isotope stage 5 or marine isotope stage 7. So it's ×3. And this is even considering the possibility of compaction during the deeper units. So this calculation is done also, the corrected means that we are considering also the compaction. This is a paper published in Global and Planetary Research in 2017 by a previous postdoc of mine. So when we check more in detail the Holocene, which is what we want to get, talking about the agriculture, so let's have a look on the last 45,000 years. And what we see here is the lamina thickness, okay? And the detrital thickness and the aragonite thickness. And both of them, they change very drastically, somewhere around 80 meters in depth, which is equivalent to around 11,000 years ago. We start to have a change in the thickness of both aragonite and detritus. And if we compare this to the local lake level stands, you can see that we can go, we go from very high levels, getting to 160 meters below sea level, to almost 400 meters. This is a great, although the graph doesn't see that, but it's a very, very great variability in the water that started already before, that is very prominent during the Holocene. And also with the global parameters of delta 018. But I was talking about detritus and aragonite. So I'm showing here, this is the typical sediment of the Dead Sea, of the Holocene, and also from the late Pleistocene. And we can see aragonite lamina of a millimeter thick, or even less, with the detrital lamina. I'm not going to get into the discussion of if this is a varve of a lamina. This is a 20 or even more years of discussion. But in general, I'm talking about lamina. It can be seasonal, it can be yearly, depending where we are in time. Nobody knows what is happening in the Pliocene, of course. But in one way or the other, we have a different, this is the Holocene and this is the Pleistocene, and we have different thicknesses when we have a look. This is the same scale here and here, the same scale here and there, okay? And we have a look, we see that the detrital lamina is much thicker in the Holocene than in the Pleistocene, Lake Lisan, and also in Lake Emora, which was even earlier. So this is to show you, to emphasize what was presented in the previous slide. And our interpretation is that the increase in the detrital lamina thickness and mean clastic sedimentation rate started already around 11.57 years ago, implying an augmentation in basin-wide erosion rates. Okay, somewhere out there. When we compare our observed clastic sedimentation rate with the general archaeological period in the Levant and other parameters that I showed before, we are suggesting that this is a direct evidence for the impact of increasing land use or the land resources on the landscape with the onset of the Neolithic revolution there. Okay, so but I was talking also about earlier time periods and early places in the Levantine Corridor. If we go and have a zoom in northern part of Israel, this is the site of Ubedia. And for those who don't know, Ubedia is world famous as the first site discovered outside Africa with early hominin remains, Homo erectus. It was found already in the 60s by Picard and Baida with this beautiful drawing that they it was found before, actually, but it was well described in 1966 by Picard and Baida. The formation has been widely studied for fossils and include a wide range of brachiopods, mollusks, and mammals. Tectonic forces have tilted and deformed the formation, which currently, though outcropping as an anticline, which is sometimes difficult to see, but in one way or the other is heavily distorted. And the formation is estimated to have been deposited 1.5 million years ago. It's estimated because we do not have a clear, chronology on this one. It's just a stratigraphical correlation. What it was being described is several big, large-scale units, full, low, fi, li, as you can see here, which is the upper fluvial, upper limnic, lower fluvial, lower limnic. And in a way, what I see here is some kind of an orbital cycle. Okay, this is what I see. But one way or the other, there is a new result coming with new findings. And we, October 2021, there was a large consortium of people, cooperation with Dr. Miriam Bellmacher from the University of Tulsa and Dr. Omri Barzilai from the Israel Antiquities Authority, in which they opened a new transect. Well, they opened the same transect, but they expanded it a little bit. And over 300 samples were retrieved from the outcrop for several studies, and they are currently being processed for geochemical and sedimentological analysis. And currently we are dealing with the physical properties of those samples. But this is the way the outcrop look like, very well sequences, very well layered, sometimes very even well laminated, with plenty of samples at high resolution of excellent work. It is being done by the different parties in this outcrop. But I'm not going to concentrate on the outcrop. In parallel, we did the core, a little bit on the side of the outcrop. We did it in an angle, which was as much as possible close to 90 degrees, as much as we could, and estimated. So the outcrop study was coupled by a 17-meter long with a core coverage of 97%, which is pretty good. It was GeoPro. The core sections were submitted to multi-sensor core logger analytical measurements, and we have measured mainly magnetic susceptibility and gamma density, but also to the physical properties such as grain size, the geochemical measurements using the XRF, and total organic carbon, among others. So far, we dealt with magnetic susceptibility and granulometry, but we're still doing our work in this project. So the Ubadia formation here, I show you the lower part of the core, which is very well laminated and very well layered. And the core appear to reach deeper layers that are not exposed in the outcrop. This is our interpretation. The deeper units are characterized, as I say, by well laminated layers. Sorry, for brown and gray clay units, showing lack of perturbation. This is important to see already. Calm water conditions, and maybe we are pointing to perhaps a high lake level stand. The new cores provide the opportunity to prove the possible orbital cyclicity of the sedimentary record and maybe help to improve the chronology by utilizing different techniques. And this is the core in general, from top to bottom. And the different colors, it was impressive, beautiful core, a very carbonate, purely limestone form in the lake. It is very obvious here, which is our marker unit to the outcrop, by the way. It's very prominent. And here I show you the grain size and the magnetic susceptibility. This is absolutely initial progress. As you can see, it's a work in progress and initial results. And in general, I see here 3 units, but we are working on that. This is one of my postdocs that I will show later. So it's an ongoing project, but one way or the other, if we are talking about 3 units or more, in general, I define the 3 units by the colors in general, but of course this is initial, but we are seeing a cyclicity in which the conditions of the lake varied through time. Here I see more brown and gray, and while here I see much less gray and more light brown. So in general, there is some kind of an internal cyclicity in something large scale. And this is only one core of 17 meters, and the entire formation is more than 150, I think. So showing you another early Pleistocene site, this will be from the southern part of Israel, and this is Lake Kuntila, this one. If we see the map of the southern part of Israel during the early Pleistocene, we will see several lakes here. Kuntila, Jaffer, El Madagoara, and Arava here. All these remains are lying out there in a region which is absolutely not supportive of those lakes today. So especially Kuntila, which was a perennial lake that existed during a pluvial interval in the early Pleistocene. The lake occupied 300 kilometers square in an area that we currently receive 10 millimeters of rain per year. So you can imagine it cannot, I mean, we didn't have that amount of rain during that time. And the sedimentary record indicates that the hydrological balance, this is what I'm saying, was totally different and was favorable for supporting a perennial relatively deep lake. If we have a look more in detail to the southern part of Israel, this is the Negev Desert and the tectonic framework. With the hydrological framework, you can see that it was an open lake system that was fed by waters in the southern part, flowing from a river to whatever was here, which is the Dead Sea in the early Pleistocene. So you need more water to be in this part of the country, which are most probably not the westerlies or not the current westerlies that as we know it. Okay. This is the site how it looked like. It's very complex to get there. It's close to Egypt. It's basically 5 meters from Egypt. The Egyptian border is after that hill. And since it's very close and very far, it takes many hours to get there, and you need authorization from the army. But we got there, and this is the outcrop, extremely paradic, as you can see, and we did a new columnar section in which we carry out eventually several measurements, the grain size, XRF, titanium, in this case, titanium and calcium, and also total inorganic carbon. And we see, according to these and more measurements, I recognize 5 different lithological sequences and 3 major time periods of upward coarsening. Or in other words, we have a relatively deep lake at the beginning and shallowing, and then another deep lake phase and another deep lake phase. And again, but more interestingly, what we saw, cooperation with Stefan Mischke from the University of Iceland. This is a paper we published last year in Frontiers. So we see here the ostracods, and the biological diversity show, although very few species of ostracods, but and that most of them are recrystalline, but we see that there is a Heuraline Cypredis torosa and few shells of Leocypris, sorry for my English, which in other words are typical for freshwater and running water, or Candona, which is freshwater. So we have a freshwater environment and we have a running water environment, okay? Not a stagnant one. And this is important to understand how much water actually was funneled during this system, which we still don't know, but also when it was funneled. And this is what we did is, together with Juan Arasvania from the University of Zaragoza, we did a paleomagnetic study here. And what you can see here is the declination, inclination, very sharp limit exactly at the middle of the formation, in which are representing a normal phase and a reverse phase. Obviously, we don't know exactly which normal and which reverse, but that unit here has archaeological artifacts of the Acheulean culture, which is 1.9 or 1.6 million years ago. And this is a study done by Guralnik and published in 2018, if I'm not wrong. And basically, this is pointing out that our normal to reverse is most probably the transition between Olduvai and CR1 and C1R, which is 1.8 million years ago. And this is, if this is true, we are pointing that the Kuntila Lake was another dot in which early hominins may had crossed and see or drink and eat when they crossed the area from Africa to Europe or back into Africa, of course, another dot apart to those that we already know. And this is an extremely very important information. We came back and went around the area back and forth to try to find more evidence for hominins. We hadn't, but it will be important to continue the study and understand better the interaction of hominins with the landscape in this environment. Let's go back even more to the Pliocene, and I hope I have time to take you to that time in the Levantine Corridor. And again, this is northern part of Israel, the Erek El Ahmar lacustrine formation. This is a 150 long formation. Let me show you this. A nice movie while I'm talking. So the formation is tilted to around 15 to 20 toward the southeast due to post-depositional tectonic activity. And the chronology. Previous studies have attempted to chronologically constrain the formation by paleomagnetism. This is a study in 2001 by Ron. And cosmogenic isotopes is a study 10 years later by Davis. In general, the sedimentary structure as a sequence is constrained between 3 and 4.5 million years, but the last word has not been said. Okay. So what you see here, this is the Jordan River exactly below the outcrop. 3 main outcrops, one here, another one far, and another one here down there in a gully, which we don't really see by this angle. But in any case, this is the Jordan River. This is Jordan basically, and this road here is the fence, the official fence bounding Israel with Jordan. So obviously to get into outcrop, or rather you cut the fence and get in jail, or rather you fly, or rather you ask permission from the army, which is what they did. And luckily they actually accepted, and we crossed the fence. There is a door there. They come, they open you the door, and then you are free to go around this part as much as you want. All the time that when you go out, you call them and they come and they close the door. To be honest, pretty convenient work in this way, and the outcrops were fantastic. So another previous study that was done in the area, not on those outcrops, there is something, a small outcrop which is 3 kilometers away, I think 3.5 something, and it's related, according to the documents to Erek El Ahmar. They found a mammoth tooth, skull, which you can see here in the pictures. However, while the finding provides a window of opportunity to learn about the Pliocene mammalia found in their area, we still don't have a clue what is the relation between this outcrop and the main one, which I showed you before. So we have a very good information here, but we don't know how to correlate this outcrop with the other one. And this is a small outcrop. It's only 7 meters, by the way. But if we come out to the main outcrop, you can see here the locations of the cosmogenic isotope. Some of them, there are more locations, but I point to those that are relevant to this talk. The previous cosmogenic ages. And we have taken more than 150 samples all along the area. And that is for understanding the paleoenvironmental conditions, and the chronology as well. Besides, we have taken a core, which is the ERK2, which is a 20-meter long core with a 95% of recovery, again with a geoprobe. And we did petrophysical analysis, magnetic, which includes magnetic susceptibility, density, and grain size as well, and geochemical measurement during the XRF. With that, we have done a relatively high resolution. So this is the core that we obtained, and the 3 major units that we define according to the lithology. And here again, it's very obvious. This is very gray, this is very brown, and this is very brownish yellow. Very, very obvious, the colors. And as you can see here, very brownish material in the top, everything is clay, and more laminated, layered, and more gray in the bottom. We have found fish, lots of fish tooths and ostracods, plenty of them, but also a mammal bone, which was found actually there. In this case, a pica, which is showing to 2 major things. One, a climate which was not as today, because we do not have picas in Israel. And 2, probably a pica that knew how to swim, because this is a lake. No kidding, but probably it was transported over there. But one way or the other, we did grain size analysis of the core and the different end members, in which they are again pointing to different possible environments, and we see that perhaps the end member 3, for instance, in the lower part is pointing to a high lake level, while a low lake level is occurring more in the top. And I will show you later with the more result that I'm showing here with the XRF. So here you can see the magnetic susceptibility and the XRF results, and the last one will be the total organic carbon and total inorganic carbon. So very obviously, you see this again, these 3 units, okay, identified in the lithology, but also in the different data sets. You can see the high organic content in the lower part in unit 1, low values of magnetic susceptibility in the upper unit, and several similar behaviors occurring in some of the elements, and which are behaving differently, similar elements in the same unit, but differently in the different through time. And when we did a statistical analysis of this, we found, and you can see here the colors of the different units, unit 1 in yellow, 2 in red, and 3 in blues. Our initial interpretation is that we are, again, finding information about the transport mechanism with, for instance, potassium showing aeolian sources, or silica and titanium and aluminum and iron showing allochthonous fluvial input, and calcium, sulfur, and chlorine showing autochthonous processes. This is our initial interpretation of the data. But also we proceed and did biomarker research, and this is also again initial study done by Dr. Isla Castañeda in the University of Massachusetts in the United States. And again, here we see something totally different between the lower part and the upper part when we are talking especially about the alkene concentration or the GVGTs concentration. And our initial interpretation is that there is a boundary there, probably lithological unit 1 to 2 or somewhere above it, in which the lower part is showing an increase in alkalinity and C4 plants, probably warmer condition, while moving slowly to an increase in C3 plants and colder conditions. It's important to mention that if you are right that there is a high total organic carbon preservation here, implying a high lake level and equilibrium, basically a layered lake with an anoxic or suboxic equilibrium condition, we are arguing that such a high lake level occurred actually when the conditions here were warmer and not necessarily colder, which is exactly the opposite of what is happening in the later in the Pleistocene and the current Holocene. But this is again initial interpretation pointing to a total different system, hydrological system. So I went through the Holocene to the Pleistocene to the Pliocene, and I will show a summary with some of the major conclusions of this presentation. For the Holocene, I show you records of detritus lamina thicknesses and clastic sedimentation rates of the Dead Sea Depot Center that indicates intensified basin erosion somewhere starting from 11.5 thousand years ago, which was a scale of 3 times higher than in the previous periods. We suggest that such a drastic depletion of vegetation, of such a drastic change in the sedimentation pattern is pointing for a change, a depletion in vegetation, followed the establishment of permanent villages, animal domestication, and agriculture, which all of them enhance the basin erosion. When we go back to the Pleistocene, we see large and deep lakes, Puntilla in the south, and Dia in the north, which appears to dominate the Levantine Corridor during the early Pleistocene. A series of measurements were done in these records, like physical, geochemical, and biological, and is currently underway, actually, in part of them. But what we see already, it appears that the Levantine Corridor, first of all, was dominated by different precipitation patterns, because you see lakes developing in areas that you don't have them today, especially considering the time frame, the age. Now, when we go back to the Pliocene, we did geochemical and initial biomarker data measured on Pleistocene records from the Erek El Ahmar formation, which show prevalence of deep water condition, perhaps temporary anoxia of the equilibrium, as I mentioned before. So it may point for favorable hydrological regime during the Pliocene that may have had facilitated early hominin migrations for the corridor. So for this, I'm not alone. I have a bunch of students behind and in the lab. So John, that soon is going to be back in the United States for his PhD. And Chrissy is already in my postdoc that she just started a new position in the US, Silas, working on Erek El Ahmar and Ubedia, that he's starting a new position in Italy. And Nimerta, my lab manager, and of course, collaboration with other entities and universities abroad. And I would like to thank you, everybody, for listening to my talk.